Hi, my name is David Leclerc. I'm with the Flow Lab here at the University of Chicago. This is the second part of a tutorial on how to use the Avalon. Here we're actually going to run some cells. I got some cells here expressing GFP. The first sample that I have in the instrument is my negative control, so we're going to run that, clicking on play here. This is the acquisition control, so I just want to have a look at the population. I just don't want to sort at this point. The first set of voltage I'm going to play with are the ones for my forward and side scatter detectors. You can see the main cluster of cells is pretty much in the middle here, so that I'm pretty happy with that. So I'm not going to change voltage at this point. And then this is my unstained population or negative population for the expression of GFP. So I can see that I get quite a bit of room on the left of that population, so I can bring that voltage down quite a bit. I have a restart button here if I want to refresh the image. The idea here is that I want to have enough room on the axis to split it positive whenever they're going to show up, yet I want my voltage to be high enough so that I have resolution power between the positive and negative fraction in my population of cells, between GFPs and positive and negative cells. At this point, I'll be able to draw my regions the way I want it, so I'm just going to record a few more events. At the bottom, you'll notice here I got the event rate, so how many cells we're acquiring per second, total number of events that we've acquired so far, required time. I can play with the pressure also at this point, so again, this is the maximum pressure because I got my three triangles are highlighted. If I click some more, 1, triangle 2, increase the speed, 3rd. If I want a specific amount of cells, event rate, I can click on that value and type in whatever amount of cells I want, so let's do 7,000 at this point. And so you'll see that the software will try to reach that value somehow. I'm satisfied with the amount of cells we've collected so far, so I'm just going to stop the acquisition at this point. I got autosave checked, so a window will pop up telling me where I can store the data. I don't really want to store any of this, but later I could make a folder and save each of these FCS files. Now I'm just going to close this. I can draw the regions I need to sort my cells. So I'm going to go to Home and use these icons here. So I'm going to use a polygon on the first graph. So I think these are the cells I want. And try to close this. There you go. Okay. So I got the R1 region that was generated. This is on my main cluster of cells. The next step is to gate on the single cells. So I can click on my graph, right click, and go to apply gate, click on R1. Now the only cells that are showing up here are the ones that are in the first gate. I want to get all the cells that have the same width on the forward scatter. So I'm going to make a rectangle and capture those. The other ones are quite likely doublets or cell aggregates. And now I want the combination of R1 and R2 to be displayed in the last graph. And so again, right click, apply gate. Now I can apply R1 and R2. These are all negative cells, so now if I draw a region to the left of that population, I'll know that if these cells, if anything falls into that R3 region, that's going to be because GFP is being expressed in these cells. So actually R3 is the population I want to sort, so at this point I can actually right click on that gate and tell the software if I want to sort left or sort right. So let's do sort to the left, and now I can actually go to sort logic and basically tell the software what we're actually going to sort. So I can sort in tubes, 5 ml, 1.5. If I had 8 well strip, I could do that, or a glass slide as well. let's do 5 ml tubes for now. I decided to sort left. Now I got 3 collection tubes I'm going to use in position 1, 3, 5. That's the position on the left side of the sorting chamber. They are odd numbers on the left side with 2, 4, 6, 8, 10. So basically just the name of the position on each side of the sorting chamber. 3 tubes then. Here I'm going to select a sorting mode, so enrich, purity, and singles are my choice. The idea here is that what happens if 2 cells end up in this droplet you're trying to sort. If one droplet is negative, the other one is positive, you have the option of sorting that droplet or not. So if you use the purity mode, you are interested in sorting a sample that will be only GFP positive cells, or only the gating you've decided. So in this case, that negative cells will not be part of your will not be sorted. If you use enrich, then what you want to do is sort as many cells as possible from the gate you selected, and so in that case the negative cell will be sorted as well, so you will sort that droplet. The single mode is if you want to sort only 1 cell per droplet, mainly if you're using cloning applications. If you really want to have 1 droplet containing only 1 cell sorted in your target. Okay, so we got purity on my first 3 tubes. The interesting thing here is that the software will prevent overflow. Basically, the software knows how big the droplet is and how many droplets will be sorted and how much volume that will generate. So if I can tell the software what's the initial volume in my collection tube, so in this case we have 1 ml in each of my collection tubes, then it will figure out when to stop on its own and move to the next sample. So I can load up to 5 tubes and never be afraid of overflowing any of my collection tubes. If I wanted to, I could sort a second population, my negative population, for example. Let's do that. It's a beautiful gate. Right. R4, I'm going to sort R4 to the right. If I go back to sort logic, now my 5 ml tubes, then I can say sort purity. Now there's way more cells here. If I wanted to, I could set a limit of cells to be sorted, so I could say I just need 500 of these R4 cells. I'm not going to do that here. Okay. At this point I can run my actual sample, so I'm going to take my sample out. I took my negative control out, put my sample, my actual sample, which some of these cells are expressing at GFP, and put that in, and now we're just going to look at how that looks. So I can see here negative population, positive one over there, so that's going to be good to sort. I can stop the acquisition at this point, save the file if I want to, and now I'll just simply start sorting. And so the sort statistic window just popped out. If it doesn't, you can bring it up using this icon here. Basically telling me how many cells have been sorted, what's the current target, so tube 1, tube 2, mode, purity, here the sort logic is 1, 2, 3, 4, and the second population is 1, 2, 3, 1, 2, 4, first one is 1, 2, and 3, volume for each population, and so on. The efficiency is what you'll want to look at. You want to make sure that this is high enough so that you're not losing too many of your cells. This will have to do with the event rate. So right now we're trying to keep at 7,000, but my sample is really small, so it's not enough cells to get there. The other thing that might affect the efficiency is just how many cells are presented on the graph. So right here, for example, I got a bunch of dots that have nothing. This is just basically noise and debris and stuff like that. It has nothing to do with the cells I'm interested in, but these are considered when I look at my sort statistics or my sort decision. So if I manage to get rid of these guys, I'm going to increase my efficiency. To do that, I'll need to play with the threshold. Basically, the threshold's minimal intensity. A signal has to be picked up by the instrument. We set it up on a forward scatter. As I increase the threshold, you can imagine a line that goes up from top to bottom on that graph here. As I move that line to the right, everything that falls below that line will disappear. So right now the threshold is set to 1. 1 has nothing to do with actual scale here. Or I don't think it does, maybe, I'm not sure. Anyway, if I move that threshold to 5, you'll see a bunch of cells will disappear when I refresh the image. So I'll use cycle mode here. Maybe a bit more time, so 5 seconds. So you can see I had a bunch of stuff on the axis here. Now my threshold has increased, and so everything that falls below that value has now disappeared, and that increased my efficiency because the software doesn't have to deal with these events anymore. Typically I would just wait half an hour or something, but we're not going to do that at this point. I'll simply stop the sort, and you can see that at this point I'm just saving the files I want, and I would simply move to the next sample. At this point you're pretty much set to run your entire experiment. You won't change any of these voltage settings, and you will simply finish your experiment. Once that is done, then you can turn off the instrument. So I'll just take my sample out. Now, it may be the case that somebody is after you on the Avalon. At that point, you simply need to log out of the instrument. You'll do that by using this icon up here, the sign out button. It's going to ask you if you want to save the protocols. You don't really want to continue, so click yes. Basically ask you to clean, so you run contrad 10%, put it on the sample arm, and put it in position. Then you can basically let the instrument clean itself for about a couple of minutes, and you don't need to stick around for that time. Basically will log you out after that cleaning period. If you're the last one in the day, then we ask of you to do a shutdown. Basically, you click on shutdown here. You sure you want to shut down? You confirm yes. Again, put the protocols to save. Basically, it starts the same way. You put the cleaning solution on the sample probe, and the instrument will clean itself for a couple of minutes. After that, a second window will show up telling you to complete the cleaning procedure. Once you click OK, then the instrument will basically shut itself down, and you don't have to stick around to finish that up. That's all I had to say about this. If you have any questions, don't hesitate to ask anybody in the Flow Lab. Thanks for your attention.